Here is the thing about machine learning. It's way simpler than people make it sound. We are basically teaching computers to spot patterns the same way you learn to tell when a friend is having a rough day. First of all, you look at a couple of factors. You look at their face and you notice they are not responding much to your jokes, or maybe their body language is a little bit off. Based on these two factors, you predict they are not in a good mood. That is pattern recognition right there. Hi everyone, I'm Abubakar, a data scientist. Today I'm breaking down machine learning, and I promise no boring textbook stuff, just the real deal about how this technology actually works and why you should care. We are talking about what machine learning really is. We will be looking at the main categories and some popular algorithms such as decision trees and linear models, where you will see this stuff in action. So hit the subscribe button if you want more data science content that makes sense, and let's jump in. There are basically three ways computers learn. We have supervised machine learning, unsupervised machine learning, and semi-supervised machine learning. Supervised machine learning is trained on a labeled dataset with human intervention, and it is applicable for predicting and forecasting. This is like learning with an answer key. You feed the computer thousands of examples where you already know the right answer. For instance, you show a kid a number of photos and tell them a dog or a cat for each one. Eventually, they will know which one is a dog or a cat when shown to them again. The same idea here. Supervised machine learning is split into two ways. We have classification and regression. Under classification, the outcome or the output is a discrete class label. This model sorts things into buckets. The computer looks at an email and decides a spam bucket or an email bucket based on patterns like sketchy subject lines, weird sender address, or too many exclamation marks. The same thing with customers. It analyzes their browsing history, past purchases, demographics to predict whether a customer will buy a product or not. Under this type, we have decision tree or random forest. The next one is regression. The outcome or the output is a continuous values, such as the price of a house, predicting actual numbers, not just categories. Instead of yes or no answers, you get specific values. For house prices, the computer considers square footage, the neighborhood, number of bedrooms, recent sale nearby, then focus that this house will sell for 200,000. Under this type of supervised machine learning, we have linear and logistic regression. Our next category is unsupervised machine learning. They do not make predictions. They only find patterns in the data set by grouping them together without human intervention. Under this type, it is a little bit trickier. No answer key this time. So we dump a pile of data on the computer and say, find interesting patterns. This type of machine learning is categorized into three, and the first one is clustering. This one does groupings based on similarities. For example, grouping customers based on the age and income. Businesses, it groups customers like budget shoppers who buy generic products, luxury buyers who don't check prices, or convenience shoppers who order everything online. The computer finds these groups without you telling it what to look for. Our next type is association. It does groupings based on their relationship of the variable in the dataset. It is usually used in market basket analysis. For example, which items are often bought together. The computer is basically saying these things tend to show up together. Our next type is dimensionality reduction. This algorithm reduces the number of variables in the dataset, but still preserves much of the information as possible, taking overwhelming information and finding what actually matters. Picture trying to describe someone's personality. You could measure a lot of traits, but really you might only need to know whether they are introverts, creative, or organized to predict most of their behavior. In business, you might track 50 metrics about customer satisfaction, but discover that response time, product quality, and ease of return processes explain 90% of whether someone is happy or not. Our next type of machine learning is semi-supervised machine learning. Sometimes you are stuck in the model. You've got some labeled data, but not nearly enough. Semi-supervised method use both labeled and unlabeled data to get better results than either approach alone. Say you have manually sorted thousands of email as spam or legit, but you got hundreds of emails more sitting there unlabeled. This approach helps you make the most of what you have. So now you understand this isn't just academic theories. This stuff runs your daily life. From the banks deciding if you will get the loan, from the doctors getting second opinion on x-rays, from your credit card company catching fraud, and even Photos app recognizing faces, and last but not the least, sales forecasting for businesses. Now let me take you through some algorithms that actually get used in the real world. Linear regression algorithm. A simple algorithm that models a linear relationship between inputs and a continuous numerical output variable. This type is applicable for stock price prediction, predicting housing prices, and predicting customer lifetime value. Our next algorithm is ridge regression algorithm. This one is part of the regression family. It penalizes features that have low predictive outcome by shrinking their coefficient closer to zero. This can be used for classification or regression, and also applicable for predictive maintenance for automobiles, sales revenue predictions. Our next algorithm is lasso regression algorithm. This one is also part of the regression family. It penalizes features that have low predictive outcome by shrinking their coefficient to zero. This can be used for classification or regression, and is applicable for predicting housing prices, predicting clinical outcomes based on health data, and others. Our next algorithm is logistic regression, a simple algorithm that models a linear relationship between input and a categorical output. This type is also applicable for credit risk score, customer churn prediction, and others. The next algorithm is decision tree. Decision tree models make decision rules on features to produce prediction. It can be used for classification or regression. This type is also applicable for customer churn prediction, credit score modeling, and disease prediction. Our next algorithm is random forest, an ensemble learning method that combines the output of multiple decision trees. This type is also applicable for credit score modeling and also predicting housing prices. The next algorithm we'll be looking at is k-mean algorithm. This type is the most widely used clustering approach. It determines the k-clusters based on distance, and it is applicable for customer segmentation and recommendation systems. Here's what we have covered today. We have learned that machine learning teaches computers to spot patterns instead of following strict rules. We have also learned that there are three main types. We have supervised, unsupervised, and semi-supervised. So this technology is already everywhere in your life, from your bank to your streaming app. Thank you for watching, and I will catch you in our next video.